You've been there. You download a file, maybe it's a free program, a game mod, or a PDF from a site that looks like it was designed in 1998. And as your mouse cursor hovers over that open button, your entire body tenses up. Every instinct, every warning you've ever heard about viruses and malware starts screaming in your head. Don't do it. This is a bad idea. But you need what's in that file. So you close your eyes, you click, and you just hope for the best. What if I told you there's a way to open that file, to run that sketchy program, to click on that weird link in a digital bomb shelter? A completely sealed-off, disposable room inside your computer where, if anything goes wrong, you can just light a match, walk away, and your actual computer remains perfectly fine, completely untouched. This isn't science fiction. This is a virtual machine. And it's one of the most powerful underutilized tools available to the average computer user. Most people think virtual machines, or VMs, are just for corporate IT nerds or super hackers in the movies. They see command lines and complex code and they just tune out. But that's a huge mistake. Because a VM is, at its core, incredibly simple. It's a computer inside your computer. Think of it like this. Your laptop or desktop is your house. It's where you keep all your important stuff. Your photos, your documents, your banking information. A virtual machine is like building a detached workshop in your backyard. You can go into that workshop and do anything you want. You can saw wood, you can weld metal, you can make a gigantic mess. You could even accidentally set the workshop on fire. But no matter what happens in there, your main house is completely safe. The fire is contained. The mess is contained. When you're done, you can just bulldoze the workshop and your house is still standing pristine. That's what a VM does for your digital life. It's a completely isolated, fully functional computer that runs in a window on your desktop. And by the end of this video, you are going to learn 5 practical, real-world uses for this technology that will fundamentally change how you interact with your computer. We're not talking about abstract theory. We're talking about solving real problems. From testing software without fear, to running old games that won't work on modern systems, to creating a completely private and secure environment for sensitive tasks. You'll learn how to have multiple computers for the price of one, all running on the machine you already own. So let's get right into it. The first, and maybe the most common reason to fire up a virtual machine, is to test drive a new operating system, completely risk-free. Let's be honest, most of us are creatures of habit. If you're a Windows user, you've probably used Windows your whole life. If you're on a Mac, you're deep in the Apple ecosystem. But you hear things. You hear your nerdy friend talk about how amazing Linux is, how it's faster, more secure, and completely free. You see articles about the new features in Windows 11 and you're curious, but you're not ready to upgrade your main machine. Or maybe you're a developer and you need to see how your website looks on a different operating system. The old way of doing this was a nightmare. It involved a process called dual booting. You had to take your hard drive and split it in half, a process called partitioning, which is always a little nerve-wracking. One wrong click and you could accidentally wipe out everything. Your photos, your music, your life's work gone. Then you'd install the new operating system on that new partition. From then on, every time you turned on your computer, you'd have to choose which one to load. Want to switch from Windows to Linux to check an email? You have to do a full shutdown and reboot. It's clunky, it's risky, and it's a huge commitment. This is where a virtual machine completely changes the game. It turns a terrifying weekend-long project into a simple 30-minute experiment. Here's how it works. You download a piece of free software. The two most popular ones are VirtualBox, made by Oracle, and VMware Workstation Player. Both have free versions that are incredibly powerful. This software is the Workshop Builder. It manages your virtual machines. Next, you download the operating system you want to try. Let's say you want to try Ubuntu, one of the most popular and user-friendly versions of Linux. You just go to the Ubuntu website and download it. It's a single file called an ISO file. It's completely free. Now you open up VirtualBox or VMware, and you click Create a new virtual machine. A simple wizard pops up and asks you some questions, just like setting up a real computer. It'll ask, what's the operating system? You'll say Linux, specifically Ubuntu. How much memory or RAM do you want to give this virtual computer? Your computer might have 16 gigabytes of RAM. You can lend, say, 4 of those gigabytes to the VM while it's running. How big of a hard drive does it need? You can create a virtual hard drive, which is really just a single big file on your main computer's hard drive. You can make it 25 gigabytes, 50, whatever you want. You're essentially telling the software, hey, pretend a piece of my physical computer is a whole new separate computer. You're carving out a small slice of your machine's power, and dedicating it to this experiment. Once you've answered those basic questions, you click Start. And what happens next is pure magic. A window opens up on your desktop, and inside that window you see a computer booting up from scratch. It's the Ubuntu installation screen. You go through the setup just like you would on a real PC. And when it's done, you have a full-fledged Ubuntu desktop running in a window on your Windows or Mac screen. You can go full screen and it feels like you're using a dedicated Linux machine. It has a web browser and Office suite, you can install software on it, you can code on it, you can do almost anything you could do on a real Linux computer. You can copy and paste between your main computer and the virtual one. You can drag and drop files back and forth. But here's the beautiful part. It is completely 100% isolated. It's in that digital workshop. If you download a virus inside that Ubuntu VM, it's trapped. It can't see or touch your main computer's files. It's like a tiger in a cage. You can study it, you can poke it with a stick, but it can't get out to harm you. And what if you mess something up? What if you're tinkering with system settings inside the VM and you break it so badly it won't even boot anymore? On a real computer, that's a crisis. You're looking at hours of troubleshooting, maybe even a full reinstallation. In a VM, you just delete it. You right-click on the virtual machine in your list, you hit delete, and poof. The entire virtual computer, that 25GB file on your hard drive, is gone. Vanished. And your main computer is perfectly fine. You can create a new one in 10 minutes. The freedom this gives you is incredible. I've personally used this to test dozens of different Linux distributions, from Mint to Fedora to Arch Linux, without ever once having to touch my stable, reliable Windows installation that I use for work. I was able to learn an entirely new operating system in a safe environment, at my own pace. When I wanted to see if the Windows 11 developer preview was any good, I didn't upgrade my main machine. I just spun up a Windows 11 VM. I played with it for a few days, decided I wasn't a fan of the new taskbar, and then I just deleted the whole thing. Zero consequences. This is the ultimate try before you buy. It removes all the fear and all the risk from experimenting, which is the heart and soul of learning about technology. You no longer have to wonder what another operating system is like. You can find out for yourself this afternoon for free. This single use case is reason enough to learn about virtual machines, but it's really just the tip of the iceberg. Because this same principle of safe, isolated computing opens up a world of other possibilities, which brings us to our second practical use. Running an entirely different operating system on your computer, without ever touching your main setup. Think of it as digital tourism. You can visit the world of Linux, or take a trip back in time to an older version of Windows, all from the comfort and safety of your current machine. Now, why would you even want to do this? For most of us, the computer we buy comes with an operating system, and that's the end of the story. If you bought a PC, you use Windows. If you bought a MacBook, you use macOS. Feels permanent, like the foundation of a house. And the traditional way to change that, a process called dual booting, is frankly terrifying for the average person. It involves partitioning your hard drive, which is like performing open heart surgery on your computer's storage. One wrong move, one misplaced click, and you could wipe out all your photos, all your documents, everything. It's a high-stakes, high-stress procedure that rightfully keeps most people locked into the ecosystem they started with. But a virtual machine completely changes the game. It removes all the risk. Instead of trying to build a new foundation next to your old one, a VM lets you build a brand new, fully functional house inside a single room of your existing one. It's a self-contained digital world. Let's take the most common example. A lifelong Windows user who's heard whispers about Linux. They've heard it's faster, more secure, more customizable, and that it's the backbone of the internet and the choice of serious programmers. The curiosity is there, but so is the fear. It looks different. The terminology is weird. You hear words like Ubuntu, Mint, kernels, and distros, and your eyes just glaze over. The last thing you want to do is replace your familiar Windows desktop with some intimidating, code-filled black screen. Here's where the VM becomes your personal guide. You download a free virtualization program like VirtualBox. Then you go to the website for a user-friendly Linux version like Ubuntu or Linux Mint, and you download a single file, an ISO file. Think of this file as the entire operating system, all of its code and graphics and programs, neatly packed into a digital box. Inside VirtualBox, you click New Machine. You give it a name like My Linux Adventure. You tell it how much of your computer's RAM and hard drive space you want to lend it while it's running. This is key, you're not giving that space away forever, you're just letting the VM borrow it. Then you simply point it to that ISO file, you download it and click Start. And just like that, a new window opens on your desktop. But this isn't just any window. Inside it, a computer is booting up from scratch. You see the Ubuntu or Mint logo appear. You go through the installation process, but it's all happening inside that safe, sandboxed window. Your main Windows system is completely untouched, running in the background, totally oblivious to the fact that a whole other operating system is being born inside of it. Once it's installed, you have a full-fledged Linux desktop. You can connect it to the internet, browse the web with Firefox, write documents in a free alternative to Microsoft Office, and explore its App Store to install thousands of free, open-source programs. You can follow tutorials and learn the basics of the command line without any fear. Because if you do something catastrophically wrong, if you accidentally delete a critical system file inside your Linux VM, what happens to your main computer? Absolutely nothing. You just close the window. You can even delete the entire virtual machine with a single click, and it vanishes without a trace. It's the ultimate undo button for an entire operating system. It transforms the intimidating task of trying Linux from a risky surgical procedure into a fun, zero-consequence experiment. But this road goes both ways. Let's flip the script. Imagine you're a student or a creative professional and you love your MacBook. You love its design, its simplicity, and the power of macOS for video editing or graphic design. But then you hit a wall. A professor assigns a project that requires a specific piece of engineering software that only runs on Windows. Or maybe there's a niche accounting program your side hustle depends on, and the developers never made a Mac version. Or let's be honest, maybe there's a massive library of PC games you're dying to play that aren't available on Mac. What are your options? Buy a whole separate Windows laptop for that one program? That's expensive and inconvenient. You could use Apple's Boot Camp to dual boot, but you're back to that risky business of partitioning your drive, and you have to shut down your Mac completely just to boot into Windows, which is a total workflow killer. Enter the virtual machine. Using software like Parallels or VMware Fusion, which are specifically optimized for the Mac, you can install a full version of Windows inside a VM. And this is where it gets truly magical. You don't just have Windows running in a boxy window. These programs have a feature, often called coherence mode, that makes the two operating systems blend together. With the click of a button, the Windows desktop disappears, but the Windows applications you open, they stay. That Windows-only engineering program is now floating on your macOS desktop, right next to Safari and your Apple Mail icon. It has its own icon in your Mac's dock. You can minimize it, resize it, and move it around just like a native Mac app. You can copy text from a web page in macOS and paste it directly into a report in the Windows program. You can drag a file from your Mac's download folder and drop it right into the Windows application. It is a stunningly seamless experience. Your Mac is still a Mac, but it now has the superpower of running any piece of Windows software you throw at it. The boundaries between the two worlds dissolve. You're no longer a Mac user or a Windows user. You're just a computer user, using the best tool for the job, regardless of its origin. This single capability is so powerful that for many professionals, it's the primary reason they can use a Mac as their daily driver without compromise. This principle extends even further for developers, IT professionals, and tech enthusiasts. Imagine you're building a website. You need to make sure it looks and works perfectly for everyone, whether they're using Google Chrome on Windows 11, Safari on a Mac, or Firefox on Linux. In the old days, you'd need a lab, a physical desk with 3 different computers, which was a nightmare to maintain, keep updated, and pay for. With virtual machines, a developer can have one powerful computer on their desk running 3 VMs simultaneously. One runs Windows, one runs macOS, and one runs Linux. They can instantly switch between them, test their code in each unique environment, and identify bugs that only appear on a specific platform. Even better, they can use a feature called snapshots. Before they install some experimental new software or make a risky change, they can take a snapshot, which is an instantaneous photo of the VM's entire state. If the change breaks everything, they don't have to waste hours trying to fix it. They just click Revert to Snapshot, and in seconds, the VM is back to exactly how it was before they made the mistake. This ability to experiment fearlessly and travel back in time is an absolute superpower for anyone who builds or tests software. So, this second use case, test driving other operating systems, is really about liberation. It's about breaking free from the digital walls we often find ourselves in. It gives you the freedom to explore, the freedom to use specialized tools, and the freedom to experiment without fear of consequence. It turns your one computer into a whole fleet of computers, each tailored for a specific task. Now that we understand we can safely quarantine an entire operating system, whether it's foreign or familiar, it opens up another, even more intriguing possibility. What if we use this isolation not just for exploration but for protection? What if we created a disposable, burner version of our own operating system, specifically for venturing into the riskier corners of the internet? That brings us to our third practical use, creating a digital fortress for high-stakes cybersecurity. Imagine your computer is your home. It's where you keep your most valuable possessions. Family photos, financial documents, private conversations, your entire digital life. Now, imagine you get a package delivered to your door. It's from a sender you don't quite recognize, and it's ticking. Do you bring it inside and open it in your living room, right next to your family photo albums and your safe? Of course not. You'd probably call the bomb squad. But on the internet, we bring ticking packages into our digital homes every single day. Every time you download a free program from a slightly sketchy website, every time you click a link in an email that seems a little too good to be true, every time you visit a web page that your browser flags as not secure, you're handling a potential digital bomb. And the problem is they don't tick. They're silent. You open the file, nothing seems to happen, and you move on with your day. But weeks later, your bank account is empty, your identity is stolen, or all your files are locked with a terrifying ransomware message demanding Bitcoin. This is the reality of the modern web. It's an incredible place, but it's also a minefield. The traditional solution has always been antivirus software. And don't get me wrong, a good antivirus is like having a sturdy lock on your front door. It's essential. But what about the threats it doesn't recognize? What about the brand new, zero-day exploits that no one has a defense for yet? What about malware that's so cleverly disguised it walks right past the security guard? The lock on your door is useless if you're the one who willingly invites the vampire in. This is where the virtual machine transforms from a cool tech toy into your personal cybersecurity black site. It becomes your digital bomb disposal unit. It's a completely isolated, sealed-off environment, a sandbox, where you can open that ticking package without any risk to your actual home. Let's make this real. Think of a time you desperately needed a specific piece of software. Maybe it was a video converter, a tool to recover a corrupted file, or a free alternative to an expensive program. You search online and you find a site that has it. But the site is covered in flashing ads. The download button is hard to find among 10 other fake, download now buttons. Your gut is screaming, this is a bad idea, but you need the software. So you hold your breath, click the button and pray. With a virtual machine, the entire equation changes. There's no more praying. There's only testing. You fire up a clean, fresh instance of Windows or Linux inside your VM. This virtual computer has no connection to your personal files. It doesn't know your passwords. It can't see your documents, your photos, or anything else on your main computer, your host machine. It's a digital ghost. Inside this safe virtual space, you open the web browser and go to that sketchy website. You click on the flashing, ad-riddled download button. You download the suspicious file. And then you run it. You detonate the potential bomb in a controlled environment. One of two things will happen. Scenario A. The program installs, it works perfectly, and it's exactly what you needed. Fantastic. You've verified it's safe. You can now consider downloading it on your main machine, or better yet, just keep using it inside the VM whenever you need it. Scenario B. The moment you run the file, your virtual desktop is flooded with pop-up ads. A fake antivirus scanner starts finding hundreds of viruses and demands your credit card number to fix them. Or worse, a ransomware screen appears, locking the virtual machine's files. On a normal computer, this would be a catastrophe, a weekend-ruining, potentially life-altering disaster. But inside the virtual machine, you laugh. You've learned what you needed to know. That file was malicious. And now for the cleanup. It's the most satisfying part. You don't need to run scanners or hire a tech expert. You simply power off the virtual machine and delete it. Poof, it's gone. Every trace of the malware, the ransomware, the pop-ups vaporized. It never touched your real computer. It was like watching a building get demolished on a TV screen. It was just pixels. Your actual home is pristine, untouched, and safe. This concept of disposability is a superpower. We can take it even further with a feature in most VM software called snapshots. A snapshot is like a save point in a video game. Before you do anything risky, you take a snapshot of your clean, perfectly working virtual machine. This saves its exact state. Then you go ahead and venture into the digital wilderness. You can click on that suspicious email link from a Nigerian prince. You can explore that weird forum. You can download and test 10 different questionable programs. You can let the virtual machine get absolutely hopelessly infected. And then, you just click Revert to Snapshot. In less than 10 seconds, your virtual machine is instantly reset to that perfect clean state you saved earlier, as if none of it ever happened. It's the ultimate undo button for your digital life. Imagine being able to do that with your actual computer, to try something, see it go horribly wrong, and just hit a button to go back in time before you made the mistake. That is the power a VM gives you. This isn't just about avoiding disaster. It's about enabling curiosity. The internet is a vast and fascinating place, but fear often keeps us in the well-lit, sanitized gardens of major corporations. We're afraid to explore. A VM is your all-terrain, hermetically sealed exploration vehicle. It allows you to be an archaeologist of the digital world, to sift through the dirt and find hidden gems without worrying about getting bit by a digital snake. It also fundamentally changes your relationship with online privacy. Every time you browse the web, you're leaving behind a trail of digital breadcrumbs. Websites use sophisticated techniques like browser fingerprinting to identify you, tracking not just your IP address, but your screen resolution, your installed fonts, your browser plugins, creating a unique signature that can follow you across the web, even if you clear your cookies. But what if you could become a different person every time you went online? With a VM you can. You can spin up a fresh, generic virtual machine that has no browsing history, no stored cookies, and a default common as dirt system configuration. To the websites you visit, you look like a brand new computer that just came online for the first time. When you're done, you can either delete the VM or revert it to a clean snapshot, wiping the slate clean. Your trail vanishes. It's a level of privacy and anonymity that's incredibly difficult to achieve on your main operating system, which is constantly accumulating data about you. So, this third use is perhaps the most empowering. It's not just about running old software or trying a new OS. It's about building a shield. It's about giving yourself a safe space to experiment, to be curious, and to defend against the very real dangers of the modern internet. It's the difference between walking through a minefield with a blindfold on and commanding a state-of-the-art bomb disposal robot from the safety of a reinforced bunker. You have the same goal, to get to the other side, but only one method gives you control, safety, and peace of mind. This idea of control, of shaping your digital environment to your exact needs, doesn't stop with security. What if you could use this same technology not just to build walls but to build bridges? Bridges to entirely different worlds of software and productivity, right from your existing computer? That brings us to our fourth and for many most game-changing use. Running a completely different operating system, side by side with your current one, without ever having to restart your computer. Think about it. For decades, we've been told to pick a side. Are you a Windows person? A Mac person? Maybe a Linux enthusiast? It's like the digital version of choosing a sports team. You buy the jersey, you learn the culture, and you defend your choice to the bitter end. Your computer, your software, your entire workflow becomes locked into that one ecosystem. If you're a lifelong Mac user, the world of Windows software might as well be on another planet. If you've spent your career on Windows, the Linux command line can feel like an ancient, indecipherable language. We live in these digital walled gardens, and the walls are getting higher every year. But what if those walls were an illusion? What if you didn't have to choose? This is the reality that virtual machines unlock. This isn't about dual booting, where you have to shut down your entire computer, cross your fingers, and reboot into a different world, completely cutting you off from your main files and applications. No, this is far more elegant. This is about running Windows as an app on your Mac, or running a full version of Linux in a window on your Windows desktop. It's not an imitation. It's not an emulator struggling to keep up. It is the real, complete operating system, running at near-native speed, neatly contained inside a virtual box. Imagine you're a video editor who has spent years mastering Final Cut Pro on your powerful MacBook Pro. You love the Mac ecosystem, but a high-paying client comes to you with a project that requires a specific plugin that only exists for a Windows-based editor. In the past, your options were grim. Turn down the job, buy a whole new Windows PC just for this one project, or go through the frustrating process of setting up a dual boot. With a virtual machine, you simply launch your Windows 11 VM, install the software, and get to work. You can even drag and drop the project files directly from your Mac desktop right into the Windows VM window. It's a seamless bridge between two worlds that were never supposed to meet. Let's break down how this superpower changes the game for everyone. First, for the massive majority of you on Windows, you've probably heard the whispers from the developer community. You've seen the tutorials online where coders are flying through tasks using a mysterious black box with green text. That's the Linux terminal. For web development, data science, cybersecurity, and server administration, Linux is not just an alternative. It's often the industry standard. The tools are powerful, the environment is customizable, and a huge amount of the internet's infrastructure is built on it. The desire to learn it is real, but so is the fear. The fear of partitioning your hard drive, of accidentally wiping out your family photos, of installing an operating system that feels alien and doesn't run your favorite games or Microsoft Office. A virtual machine completely removes that fear. You can download Ubuntu, one of the most popular and user-friendly versions of Linux, for free. You can install it in a VM in under 20 minutes with zero risk to your main Windows system. Suddenly, you have a perfect self-contained Linux environment. You can follow along with those coding tutorials, you can learn to use powerful command line tools like grep and awk, you can compile software, and you can host a local web server for your projects. If you mess something up catastrophically, if you delete a critical system file inside the Linux VM, you just delete the VM and start over. Your Windows machine remains untouched, safe and sound. It is the ultimate digital sandbox for professional development, transforming your Windows PC into a versatile coding workstation. Now let's flip the script. Let's talk to the Mac users. You've chosen an ecosystem known for its design, simplicity, and creative prowess. But let's be honest, there are pockets of the software world that Apple's ecosystem just doesn't cater to. Maybe it's a piece of niche engineering software like SolidWorks, or a specific financial modeling program your company uses that is, and always will be, Windows only. Or maybe, just maybe, you want to play a massive library of PC games that are not available on macOS. A virtual machine running Windows is your golden ticket. Using software like Parallels, which is optimized for this very purpose, you can run Windows so smoothly on your Mac that it feels like magic. Their coherence mode even lets you run Windows applications as if they were native Mac apps. You can have a Microsoft Excel window running right next to your Mac's Pages document. You can put a Windows app in your Mac's dock. You're no longer making a compromise. You're getting the best of both worlds. The elegance and power of macOS for 95% of your work, and a fully featured Windows PC, available on demand, for that other 5%. You don't have to own two computers. You just need one Mac that can be two computers at once. And of course, this bridge runs in all directions. For the Linux power users out there, you know the freedom of open source, but you also know the occasional frustration. You need to file your taxes with a specific piece of software that only runs on Windows. You need to collaborate on a document with a colleague who insists on using a specific feature in the latest version of Microsoft Word. Or you just want to use Adobe Photoshop without jumping through hoops. A simple, lightweight Windows VM is the clean, pragmatic solution. It keeps your main Linux environment pure and dedicated to your work, while giving you an escape hatch to the proprietary software world whenever you need it, without compromising your principles or your workflow. What we're talking about here is more than just a technical trick. It's a fundamental shift in how you can use the computer you already own. It's about breaking free from the limitations imposed by corporate ecosystems. It allows you to choose the best tool for the job, regardless of what operating system it was designed for. It makes you a more versatile, more capable, and more knowledgeable computer user. You're no longer just a Windows person or a Mac person. You become a person who can operate in any digital environment, a person with a universal key to any software door. We've now covered using VMs to quarantine threats, to test software in a clean room, to preserve our digital past, and to build bridges between warring operating systems. We've built walls for safety and bridges for productivity. But there is one final, fifth use. One that takes all of these concepts, isolation, replication, and control, and turns them inward, not to run someone else's software, but to build and run your very own private, powerful services for yourself and your family. How would you like to have your own personal cloud, your own media server, your own ad blocking network, all running silently and securely on a single machine you already have? This is the third, and for many people, the most transformative use case for a virtual machine on your personal computer, turning it into a powerful, private, all-in-one home server. Let's unpack that. The word server sounds intimidating, right? It conjures up images of massive, windowless rooms filled with blinking racks of computers, run by a team of hyper-caffeinated geniuses. But at its core, A server is just a computer that provides a service to other computers. And with a virtual machine, you can run multiple, dedicated, professional-grade servers right inside that PC sitting on or under your desk, without affecting your ability to browse the web, play games, or get your work done. This isn't about running some big corporate website. This is about self-hosting. It's about taking back control of your digital life from the big tech companies and running your own services for your own benefit. Let's start with one of the biggest pain points of modern digital life: the cloud. We all use it. Google Drive, Dropbox, iCloud, OneDrive. We entrust them with our most precious files. Family photos, sensitive documents, creative projects. And in return, we pay them a monthly fee. We agree to their terms of service, which can change at any time. We accept that our data is sitting on their computers, in a location we don't know, subject to their security, their privacy policies, and their potential mistakes. If they decide to lock your account for any reason, you can lose access to everything. You're essentially renting a digital storage locker, and the landlord has a key. What if you could own the building instead? With a virtual machine, you can. You can set up a lightweight Linux VM. And don't worry, you don't need to be a Linux expert. The community has made this incredibly easy. And install software like Nextcloud or OwnCloud. In about an hour, you can have your very own fully featured private cloud service. It's a perfect clone of Dropbox, but the only computer it runs on is yours. The only person with the key is you. Think about what this means. Your storage limit is no longer 15 gigabytes or 2 terabytes. Your storage limit is the size of the hard drive in your computer. You can buy a massive 10 terabyte drive for a one-time cost that's less than 2 years of a premium cloud subscription, and you'll have 5 times the space. There are no more monthly fees. None. You can install the Nextcloud app on your phone, and just like Google Photos, it can automatically back up every picture you take, saving it directly and securely to the computer in your home office. You can install the client on your laptop, and you'll have a folder that syncs instantly across all your devices. You can generate a secure link to a file and send it to a friend just like a Dropbox link. You can even use its built-in Office suite to collaborate on documents with your family in real time. It's your own private Google Workspace, your own private Dropbox with no one looking over your shoulder. And because it's in a VM, it's completely isolated from your main operating system. It just runs silently in the background, a secure digital vault that you, and only you, control. But let's not stop there. What about entertainment? How many streaming subscriptions are you paying for right now? Netflix, Hulu, Disney+, Max, Peacock, it's a mess. Content appears and disappears based on licensing deals. You pay for a premium plan, and then they add an ad-supported tier and raise your price. The dream of a single, simple library of everything has fractured into a dozen expensive, confusing apps. This is where you can build your own personal Netflix. Using a VM, you can set up a media server with software like Plex or Jellyfin. This is, without a doubt, one of the most popular and rewarding self-hosting projects. You take all of your own media, DVDs and Blu-rays you've legally ripped, old home movies you've digitized, music you've collected over the years, and you put it all in one folder on your computer. Then you point your Plex server, running in its own little virtual machine, to that folder. And then the magic happens. Plex scans everything. It automatically identifies every movie and TV show, downloads stunning poster art, cast information, plot summaries, and even theme music. It organizes it all into a beautiful, intuitive interface that looks and feels just as polished as any major streaming service. Your chaotic folder of files is transformed into your personal, perfectly curated library. Now you can install the Plex app on your smart TV, your Roku, your phone, your tablet, your game console, anything. And you can instantly stream any of your media to any of those devices, anywhere in your house, or even anywhere in the world. You can be in a hotel room on the other side of the country, open the Plex app on your laptop, and watch a movie that's being streamed directly and securely from the PC in your home office. You can even share your library with your parents or your kids, so they can access your family's collection. No more subscription fees. No more wondering which service has that one movie you want to watch. It's all there in your library forever. And by running it in a VM, it's on 24/7, ready to serve you without slowing down your main computer one bit. Okay, so we've taken back control of our files and our media. What about our browsing experience itself? Ads. They are the plague of the modern internet. They slow down websites, they burn through your mobile data, they track your every move, and they're just plain ugly. You can install an ad blocker in your browser, and that's a great start. But what about the ads in the apps on your phone? Or the ads built into the main menu of your smart TV? A browser extension can't touch those. but your personal server can. This brings us to one of the most brilliantly simple and effective self-hosted services. You can run Pi-hole. The name is perfect. It's a black hole for internet advertisements. You set up another tiny, extremely low-resource virtual machine. It can run on less than 1 GB of RAM. You install Pi-hole on it, which is a simple automated process. Then you make one small change in your home's internet router settings. You tell it to use your Pi-hole VM as its DNS server. Now let's demystify that. Every time you go to a website, your device first has to ask a DNS server, "Hey, what's the actual numerical IP address for google.com?" The DNS server tells it, and your device connects. Pi-hole cleverly inserts itself into that process. When a website tries to load an ad from, say, doubleclick.net, your device asks the Pi-hole, "Hey, what's the address for this ad server?" And the Pi-hole simply responds with nothing. It sends it into a black hole. The ad never even gets downloaded. The request is blocked at the network level before it ever reaches your device. The effect is immediate and profound. Suddenly, websites load faster. The clutter is gone. But the real magic is that this works for every single device on your network. Your phone's apps become ad-free. The games your kids play on their tablets are no longer filled with annoying pop-ups. Your smart TV's interface is clean. And as a massive bonus, because Pi-hole blocks the domains of known trackers, it provides a gigantic boost to your entire household's privacy. You get a dashboard that shows you just how many thousands, or even hundreds of thousands of ad and tracking requests it has blocked for you. Running these 3 services, a private cloud, a personal media server, and a network-wide ad blocker, on a single physical computer is the superpower that virtualization gives you. Each service is neatly contained in its own isolated, secure virtual machine. They don't interfere with each other, and they don't interfere with your primary operating system. You've transformed a simple personal computer from a device that just consumes content and services from giant corporations into a powerful private hub that provides those same services back to you and your family, on your own terms. You're no longer just a renter in the digital world. You're a homeowner. And what does a homeowner do? They don't just pay the bills and mow the lawn. They build, they improve, they create a space that reflects who they are. But they also preserve. They keep old photographs in the attic. They hold on to their grandfather's old tools, not just for their utility, but for the stories they tell. Our digital lives are no different. We accumulate a history, a digital patina of memories, projects, and experiences. But technology has a brutal, unsentimental relationship with the past. It moves forward relentlessly and it leaves things behind. Think about it. That old hard drive in your desk drawer. The stack of CD-ROMs in a box in the closet. They're like digital time capsules, but the keys have been lost to time. The software needed to open those files, to run that game, to access that project you poured your heart into in college. It's gone. It won't install on Windows 11. It gives you some cryptic error message or just silently fails. A digital ghost refusing to appear. We've been conditioned to accept this as a fact of life. Digital things fade. Your first website, built with GeoCities tools. Your family tree, meticulously crafted in a program from 1998. That incredible game you and your friends spent an entire summer playing. They exist only as memories locked away on obsolete media, unreadable by the gleaming, powerful computers we use today. It's a quiet, slow-motion tragedy. We are creating more data than ever before, yet we are also creating a generation of digital orphans, files without the applications that gave them life. But what if it didn't have to be this way? What if you could build a bridge to the past? This brings us to our 5th and perhaps most profound practical use for a virtual machine: creating a digital time capsule. A perfectly preserved environment where your old software, your old files, and your old memories can live and breathe again. A virtual machine isn't just a separate computer running on your computer. It can be a separate era running on your computer. You can install Windows XP, Windows 98, even Windows 3.1 in a virtual machine right on your desktop. Think of it as building a perfectly clean, climate-controlled room in your digital home, specifically designed to house these delicate artifacts from a bygone digital age. The process is nothing short of magic. You start by finding a disk image and ISO file of the old operating system you need. The Internet Archive is a fantastic resource for this, a digital library of Alexandria for old software. You then fire up your virtualization software like VirtualBox or VMware, and tell it you want to create a new machine. You give it a name, maybe Windows XP Nostalgia Box. You assign it a tiny amount of your computer's resources. An old operating system like XP is laughably lightweight by today's standards. It will run happily with a single processor core and a gigabyte of RAM, barely making a dent in your modern machine's power. Then, you point the virtual machine to that ISO file and turn it on. And you watch. You watch as a familiar logo appears. A startup sound you haven't heard in 15 years fills your speakers. You go through the installation process, a ritual you thought was lost to time. And in a matter of minutes, you have a pristine, fully functional Windows XP desktop, running in a window on your state-of-the-art PC. The first time you do this, it's a genuine thrill. Feels like you've broken a fundamental law of technology, and this is where the real magic begins. Using a shared folder, you can easily drag and drop those old files from your modern computer directly onto the desktop of your virtual Windows XP machine. That old installer file for a game that you've kept for 2 decades? Double-click it, and it runs. The installation wizard pops up, asking you where to install. It finishes and an icon appears on the desktop. You click it, the screen flickers, the resolution changes, and suddenly you're back. You're back in that world you thought you'd lost forever. The music, the graphics, the feeling. It's all perfectly preserved. This isn't just about gaming, though. Think bigger. That old genealogy program with your entire family history? It runs. Those photos from your first digital camera, trapped in a proprietary Kodak format? The software installs and your photos are there, crisp and clear. That portfolio you built in an ancient version of Macromedia Director, the one that landed you your first real job? You can open it and show your kids what you used to build. You are no longer at the mercy of planned obsolescence. You are the curator of your own digital museum. You can explore the encyclopedias that came on CD-ROMs, like Encarta with their quirky videos and articles. You can run old educational software, the Oregon Trail, Mavis Beacon teaches typing, Reader Rabbit, and share a piece of your childhood with a new generation. It's an incredibly powerful way to connect with your own past. Now, it's not always a perfectly smooth ride. Sometimes it's a treasure hunt. You might need to track down specific drivers for the virtual hardware, or find a community-made patch to get a program running. Websites and forums dedicated to abandonware and retro computing become invaluable resources. But the hunt is part of the fun. It's an archaeological dig into your own history, and the tools within the virtualization software make it easier than you'd think. Creating snapshots allows you to save a perfect state of your virtual machine. If an installation goes wrong, you can rewind time with a single click back to a point before you started. It's a safety net that never existed on the physical hardware of the past. This is what it truly means to be a digital homeowner. You're not just living in the present, you're honoring the past. You're building an archive, a library, a playroom filled with the digital toys of yesteryear. You're ensuring that your story, your work, and your memories are not lost to the relentless march of updates and upgrades. You are in control. You decide what gets preserved. By using virtual machines to create these digital time capsules, you're fundamentally changing your relationship with technology. You're transforming it from something that dictates what you can and can't access into a tool that serves your needs across time. We've seen how VMs can protect us in the present, how they can let us experiment with different futures, and now how they can reconnect us with our past. But this power to control and isolate digital environments has implications that go far beyond just one machine. What if we could take this principle of isolation and control and apply it to our entire digital life, to our entire network? What if we could build not just a secure room but a digital fortress? That's where we're going next. It's a fortress built not of stone and mortar, but of pure logic and code. A place where you and you alone are the architect, the gatekeeper, and the watchman on the wall. This isn't science fiction. It's the fourth practical use for a virtual machine on your personal computer. Creating your own private, isolated network laboratory. Think about your home network right now. You have a router from your internet provider, and everything connects to it, your computer, your phone, your smart TV, maybe even your refrigerator. They all talk to the internet, sending and receiving data constantly. But do you know what they're saying? Do you know who they're talking to? For most of us, the answer is no. It's like living in a house where the front door is constantly open, with a crowd of strangers and messengers coming and going, and you have no idea what messages they're carrying. A virtual machine allows you to build a new house, a secure house right inside your computer. And not just a house, but an entire self-contained neighborhood with its own roads, its own traffic rules, and its own gate to the outside world. Here's how it works. Instead of just creating one virtual machine running, say Linux, you create several. But you configure them in a special way. You create one specific VM to act as a router and a firewall. Let's call this the Gatekeeper VM. Think of it as the single, heavily guarded drawbridge to your digital castle. You can install powerful open-source software on it like pfSense or OpenSense, tools that are used to protect the networks of massive corporations, but you can run them for free right on your PC. Then you create other virtual machines. Maybe one is a standard Windows machine. Maybe another is a Linux server. But here's the crucial part. You configure them so that they can't talk to the real internet directly. Their only path to the outside world is through your Gatekeeper VM. Suddenly, you have absolute power. You're no longer just a resident in the house. You are the architect of the entire city's infrastructure. Every single piece of data, every packet of information that wants to leave your virtual network or enter it, must pass through your Gatekeeper for inspection. What does this let you do? This is where it gets incredibly powerful. First, let's talk about security and learning. This setup is the ultimate cybersecurity training ground. It's a dojo where you can practice and learn without any risk of breaking your main computer or your home network. You can set up one of your virtual machines to be a deliberately vulnerable target, maybe an old unpatched version of Windows. Then, on another VM inside that same private network, you can install a security toolset like Kali Linux. From your attacker machine, you can then learn to probe the victim machine for weaknesses. You can see firsthand how a vulnerability is exploited. You can watch how malware might try to spread from one machine to another within a network. And all of this happens in a completely sealed environment. It's like having a chemistry lab where you can mix volatile chemicals together, but they're inside an unbreakable, transparent box. You can see the reaction, you can study it, but there's zero chance of it blowing up in your face. You can take it a step further. On your Gatekeeper VM, you can install an intrusion detection system, or an IDS. This is like a set of laser tripwires and motion detectors for your network. As you run your simulated attacks, you can watch the IDS light up. You can see it detect the suspicious activity in real time, logging the exact type of attack you're attempting. You're not just reading about cybersecurity in a textbook. You are living it. You are the attacker, and you are the defender simultaneously. This hands-on experience is something you simply cannot get any other way. And it's a fundamental skill for anyone interested in a career in information security. But this isn't just for aspiring hackers and security pros. This has profound implications for your everyday privacy. Let's go back to that idea of your devices constantly phoning home. With a virtual network, you can start to unravel this mystery. You could, for example, route the traffic from a specific application or even a simulated smart device VM through your Gatekeeper. Then you can use tools to watch the traffic. You might be shocked at what you find. You might see an application you trust sending data to ad trackers you've never heard of. You could see it connecting to servers in countries you weren't expecting. This isn't about paranoia. It's about awareness. It's about pulling back the curtain on the invisible data flows that define our modern lives. And you can do something about it. Inside your virtual network, you can set up another specialized VM to act as a DNS filter. A popular tool for this is called Pi-hole. Think of it as a bouncer for your network's address book. When any of your other VMs try to connect to a known ad server or a malicious domain, the Pi-hole VM simply says, "Nope, that address doesn't exist," and the connection is dropped before it even starts. You can watch in real time as thousands of requests to trackers and ad networks are blocked, cleaning up your web browsing experience and enhancing your privacy. By running this in a virtual lab first, you can perfect your block lists and configurations before ever considering deploying something similar on your actual home network. Imagine the confidence this builds. You start by not knowing what's happening on your network. Then, you build a small virtual copy of a network. You learn to watch the traffic. You learn to identify what's normal and what's suspicious. You learn to install a firewall and write rules to block unwanted connections. You learn to deploy defenses that actively hunt for threats. You go from being a passive consumer of technology to an active, empowered commander of your own digital domain. This concept of virtual networking is the bedrock of the modern internet. It's how cloud providers like Amazon Web Services and Google Cloud can serve millions of customers from the same physical hardware. They create logically isolated virtual networks for each client, ensuring that one customer's data and traffic is completely invisible and inaccessible to another. By building your own little version of this on your home PC, you are gaining a fundamental understanding of how the entire cloud works. It's a paradigm shift. Your computer is no longer just a single device. It becomes a chameleon. a host for an entire ecosystem of interconnected machines that you can create, modify, and destroy at will. You can simulate a small business office with a server and several workstations. You can test how a software update might affect multiple computers before you deploy it for real. You can create a pristine, clean network environment for sensitive tasks, completely separated from your day-to-day, cluttered digital life. We started this journey by talking about a single padded room, a sandbox to test one application. Now we've built an entire fortress, a complex of buildings with walls, gates, and guards, all existing as pure data on your hard drive. We've mastered the art of isolation, of creating a sealed-off world to protect ourselves from the internet and to safely study its dangers. But what if we want to do the opposite? What if, instead of hiding from the internet, we want to offer something to it? What if you want to run your own website, your own personal cloud storage, or your own media server that you can access from anywhere in the world? Doing that from your main personal computer is a massive security risk. It's like putting your family photo albums on a table on your front lawn. But what if you could use a virtual machine as a dedicated, hardened outpost? A public-facing server that sits outside your main fortress walls, designed to interact with the world while keeping your personal data safely locked away inside. How do we turn our private fortress into a public embassy? That is the final and perhaps most transformative use we are about to explore. This fifth and final use case is where we take the isolated, hardened fortress we've built and give it a purpose that faces the outside world. We are going to turn our virtual machine into a server. Now hold on. I know the word server can conjure up images of massive, windowless buildings filled with blinking lights and a constant, deafening hum. And while that's true for the servers that run Google or Amazon, the fundamental concept is much, much simpler. A server is just a computer that provides a service to other computers. Your laptop right now could be a server. And a virtual machine, a computer within your computer, is one of the absolute best ways to create one for yourself. Why? For all the reasons we've already discussed, but amplified. The number one reason is isolation. When you open a port to the internet, you are creating a doorway into your network. If you host a server directly on your main computer, that doorway leads straight into your digital living room, where your family photos, your financial documents, and your personal files all live. It's a risk. But when you host that server inside a virtual machine, that doorway leads to a specially designed, isolated guest house. If someone nefarious tries to break in, or if the software has a vulnerability, the damage is contained entirely within that virtual machine. Your main computer, your digital home, remains untouched and unaware, protected by the digital walls of the hypervisor. It's the ultimate security buffer. The second reason is management. Let's say you spend a week perfectly configuring a web server. You get all the settings just right, the performance is tuned, and it's running beautifully. With a VM, you can take a snapshot, a perfect instantaneous copy of that entire machine state. Then you can experiment. Try to install new software, change a critical setting, and if you break everything, you don't spend the next 3 days trying to fix it. You just click a button and restore the snapshot. You're back to a perfect working state in less than a minute. It's like having an undo button for an entire computer. Furthermore, it keeps your main operating system pristine. Server software can be complex, installing dozens of background services and dependencies. By containing it all within a VM, you avoid cluttering up your primary machine. When you're done with the server, you don't uninstall it. You simply delete the virtual machine file, and it's gone without a trace. So, what kind of servers could you actually run? This is where it gets really exciting. Let's start with something classic: a personal website. Maybe you're a developer who wants a portfolio, a photographer who wants to showcase your work, or you just want to run a family blog. You can spin up a Linux virtual machine for free and install what's known as a LAMP stack: Linux, Apache, MySQL, and PHP. This is the foundation that runs a huge portion of the internet. Inside this VM, you can build and test your website in a live environment that's completely offline and private. You can break it, fix it, and perfect it. And when you're ready, you can learn how to configure your home network to make that website, running in a tiny virtual box on your laptop, visible to the entire world. You get hands-on experience with web hosting, without paying a dime for a hosting service. But let's get more practical for everyday life. How about your own personal Netflix? I'm talking about a media server. Software like Plex or Jellyfin allows you to take your own collection of movies, TV shows, and music and stream them to any device, anywhere. You can install the Plex server software inside a virtual machine and point it to your media library. This VM can then run 24/7 in the background. It handles the heavy lifting of transcoding, converting video files on the fly to play on your phone, your tablet, or your TV in the living room. Your kids can be watching a movie in their bedroom, you can be watching a show on your iPad, all served from that one VM. And because it's isolated, it doesn't interfere with your main computer's performance. If the media server crashes, it doesn't take your whole system down with it. You've created a robust, personal streaming service for your entire household. For the gamers out there, this next one is a game changer. You can host your own private game server. Think about it. A persistent world for you and your friends in games like Minecraft, Valheim, or Ark, Survival Evolved. Instead of paying a monthly fee for a hosting company, you can create a virtual machine, allocate a few CPU cores and some RAM to it, and install the dedicated server software for your favorite game. You have complete control. You can install any mods you want, you can set the rules, and you can turn it on or off whenever you please. When your friends want to play, they connect directly to your server. When you're done, you can just shut down the VM, freeing up those computer resources for your own gaming. It's the ultimate private sandbox, built and controlled by you, running securely in an isolated corner of your own PC. And for the final and perhaps most powerful example, you can create your own private cloud. We've all become accustomed to services like Google Drive, Dropbox, or iCloud. They're convenient, but they come with a trade-off. You're handing your personal data over to a massive corporation. Your files, your photos, your contacts, your calendars, they all live on someone else's servers. With software like Nextcloud, you can change that. You can install Nextcloud on a Linux VM and create your very own self-hosted cloud. You can have a folder on your computer that syncs to your server just like Dropbox. You can have an app on your phone that automatically backs up your photos to your own server, not Apple's or Google's. You can sync your contacts and calendars across all your devices. It's your data on your hardware under your control. The virtual machine becomes your personal data embassy, a service you provide to yourself, securing your digital sovereignty. Now, making these servers accessible from outside your home network involves a step called port forwarding on your router. It's essentially the act of telling your router, hey, any traffic that comes asking for this specific port or door number, please send it directly to the front door of this specific virtual machine. It's a crucial step, and it also underscores the importance of security. When you open that door, you must be vigilant. This means using strong, unique passwords for everything, keeping your server software constantly updated to patch vulnerabilities, and configuring the VM's own firewall to only allow the connections you absolutely need. The journey we've taken with the virtual machine is transformative. We started with a simple, disposable box for testing sketchy software. We evolved it into a time machine for running old operating systems and a chameleon for trying out new ones. We hardened it into a secure vault for our most sensitive tasks and a sterile laboratory for digital forensics. And now, with this final step, we've turned it outward, creating a public-facing embassy that can serve websites, media, games, and even our own private cloud to the world, all while keeping our personal digital lives completely safe and separate. The virtual machine is not just another program. It's a fundamental shift in what your personal computer is capable of. It's a stage upon which you can build and run entire digital worlds. And for some, those digital worlds aren't just for exploration, they're for creation. This brings us to our fourth practical use: turning your personal computer into a professional-grade development and testing environment. If you've ever heard a programmer joke about the dreaded phrase, "Well, it works on my machine," you've stumbled upon one of the biggest headaches in software development. An application might work perfectly on a developer's computer, but then completely fall apart when it's moved to a server or a customer's device. Why? Because the environments are different. A tiny difference in a software version, a missing file, a setting that was changed months ago and forgotten. Any of these can cause catastrophic failures. This is where the virtual machine becomes the developer's most trusted ally. It's a clean room, a sterile laboratory where you can build and test software in a perfectly controlled environment. Imagine you're building a web application that needs to run on a very specific version of Linux, say Ubuntu 22.04, with a particular version of the Python programming language and a specific database. Instead of trying to install all of that on your main Windows or Mac machine, creating potential conflicts with your existing software, you simply spin up a virtual machine. You install that exact version of Ubuntu, the correct Python, the right database. You create a perfect replica of the production server. Now, when you write your code and test it inside that VM, you have a much higher degree of confidence that if it works here, it will work there. The "it works on my machine" problem starts to fade away. But it gets even better. What if your application needs to support multiple systems? Let's say you're building a cross-platform desktop app. You need to ensure it works flawlessly on Windows 10, Windows 11, the latest Mac OS, and a popular Linux distribution. Are you going to buy 4 separate computers? Of course not. On your one powerful host machine, you can run 4 different virtual machines simultaneously. One with Windows 10, one with 11, one with Mac OS, and one with Linux. You can drag and drop your application file between them, testing and debugging in real time across every environment you need to support. This capability used to be the exclusive domain of large corporations with massive testing labs. Today, it's available to anyone with a modern personal computer. However, the true superpower that virtual machines give to developers is a feature called snapshots. A snapshot is an exact, instantaneous photograph of the entire state of your virtual machine, the memory, the hard drive, everything. Freezes a moment in time. Think about the implications. Let's say you're about to try something risky. You need to install a new, experimental piece of software, or you're going to make a major change to the system's configuration that could potentially break everything. On a physical machine, this is a moment of high anxiety. You'd make backups, cross your fingers, and hope for the best. If it goes wrong, you could be spending hours or even days trying to fix it. In a virtual machine, you simply take a snapshot. Takes a few seconds. Then you proceed with your risky operation. If it works, great. If it completely destroys the operating system, corrupts all your files, and makes the whole thing unusable, you don't even flinch. You just click revert to snapshot. And in the time it takes to get a cup of coffee, your virtual machine is back to the exact state it was in moments before you took the snapshot. It's a time machine. It's an undo button for your entire operating system. This feature fundamentally changes the way you can work. It encourages experimentation. It removes the fear of failure, allowing for faster innovation and more robust development. The ability to create these disposable, reproducible, and time-traveling environments is why virtualization is not just a tool, but a cornerstone of modern software engineering. This power to build, break, and reset digital worlds without consequence isn't just for professionals, which leads us to our 5th and perhaps most empowering use case: using a virtual machine as the ultimate educational sandbox. Curiosity is a powerful force, but it's often held in check by fear. You want to learn how an operating system really works, but you're afraid of deleting a critical system file on your main computer. You're fascinated by cybersecurity, but you're afraid of accidentally downloading a real virus. You've heard amazing things about Linux, but the idea of reformatting your hard drive and installing a new operating system is terrifying. The virtual machine removes that fear. Want to finally learn Linux? This is without a doubt the best way to start. You can download an image of Ubuntu, Mint, or any other distribution for free. You can create a new virtual machine, and in less than 15 minutes, be running a full-featured Linux desktop in a window on your current operating system. You can browse the web, install software, and learn the command line. And here's the beautiful part. You have complete freedom to mess up. Go ahead. Follow that online tutorial that tells you to type a scary-looking command into the terminal. What's the worst that can happen? You break the virtual machine. If you do, you just delete it and create a new one. The stakes are zero. Your main computer, your precious photos, your documents, they are all completely untouched and safe. This risk-free environment has been the gateway for millions of people to discover the power and flexibility of the Linux world. This concept extends far beyond just trying a new operating system. It creates a personal laboratory for any kind of computer science education. Are you interested in cybersecurity? This is an absolute game changer. You can set up your own virtual lab. For example, you can create 2 virtual machines. On one, you install an operating system designed for security testing like Kali Linux. On the other, you install an older, intentionally vulnerable version of Windows. You then configure them to only be able to talk to each other on an isolated virtual network. Now you have a personal ethical hacking range. You can safely and legally practice scanning for vulnerabilities, exploiting weaknesses, and learning how cyber attacks actually work, all without ever touching a real network or breaking any laws. This hands-on experience is invaluable and simply impossible to get safely without virtualization. The same goes for networking. Reading about how IP addresses, subnets, and firewalls work is one thing, but building it yourself is another. You can create 3, 4, or even 5 virtual machines and design your own mini-internet. You can make one VM act as a server, another as a client, and a third as a router or firewall that sits between them. You can then watch the traffic, block certain connections, and see the cause and effect in real time. You can build a virtual representation of the very networks that power our world, right there on your laptop. Ultimately, the virtual machine is the embodiment of the freedom to fail. In a world where our digital lives are so important and our computers are so essential, we've become hesitant to experiment. We don't want to break the tools we rely on. Virtualization gives us that permission back. It creates a consequence-free space where curiosity can thrive. It lets you tear down an engine to see how it works, knowing you can reassemble it with a single click. It's a flight simulator for computing, where you can try daring maneuvers and push the limits, secure in the knowledge that your real-world plane is safe on the tarmac. This transformation of your PC from a static tool into a dynamic, ever-changing laboratory for learning and experimentation is perhaps the most profound value a virtual machine can offer. It unleashes your potential by giving you a world where mistakes are not just tolerated, but are a welcome and essential part of the learning process. And this is where the true magic lies. It transforms your computer from a simple appliance, a tool for consumption, into a laboratory for creation. It's a fundamental shift in your relationship with technology. You're no longer just a passenger. You're in the driver's seat with a map to anywhere you want to go, and the freedom to take any detour that sparks your curiosity. So let's take a step back and look at the picture we've painted together. We started with a simple question. What are the practical uses for a virtual machine on your personal computer? And the answers we found are not just about technical tricks. They're about solving real, everyday problems and unlocking new capabilities you might not have thought possible. We talked about building a digital fortress, a secure sandbox where you can open that suspicious email attachment or click on a weird link without risking your entire digital life. That's not just a feature, that's peace of mind. It's the ability to navigate the wild west of the internet with the confidence of a sheriff, knowing your real data, your family photos, your financial information are all safe and sound, completely isolated from the chaos. We explored the world of software compatibility, turning your modern, high-powered machine into a time-traveling device. You can run that ancient, beloved piece of software your business still relies on, or boot up that classic video game from your childhood, all without messy dual booting or hunting for a 20-year-old computer in a thrift store. It's about preserving access to the tools and experiences that matter to you, regardless of what the latest operating system update decides is obsolete. We saw how a VM can be a chameleon, allowing you to run multiple operating systems simultaneously. You can have the creative power of macOS, the development-friendly environment of Linux, and the universal compatibility of Windows all running on a single laptop at the same time. This isn't just about convenience. It's about workflow optimization. It's about breaking down the walls between digital ecosystems and building a unified workspace that is perfectly tailored to your unique needs as a creator, a developer, or just a power user. And finally, we touched on the most powerful use of all: education. The virtual machine as the ultimate playground, a place to install, break, fix, and experiment with entire operating systems. A place to learn networking by building a virtual network of machines, to understand cybersecurity by setting up your own vulnerable targets to attack in a safe, ethical environment. This is hands-on learning in its purest form, where the cost of failure is zero, and the potential for growth is limitless. But here's the most important takeaway, the thread that connects all these uses. Mastering virtualization is more than just a hobby. It's developing a foundational skill for the future of technology. When you hear about the cloud, what do you think that is? It's not a fluffy white thing in the sky. At its core, cloud computing, whether it's Amazon Web Services, Microsoft Azure, or Google Cloud, is built on the very same principles of virtualization we've been discussing. They are just using unimaginably powerful computers to run thousands of virtual machines for their clients. By learning how to manage a VM on your own laptop, you are gaining a fundamental understanding of how the backbone of the modern internet works. You're learning the language of server administration, of resource allocation, of network configuration. This knowledge is incredibly valuable. It's a skill that translates directly to careers in IT, in cybersecurity, in software development, and in DevOps. It's a line item on a resume that shows you're not just a user of technology, but someone who understands how it's built from the ground up. So how do you start? How do you go from watching this video to actually launching your first virtual machine? It's probably easier than you think. Let's break it down into 3 simple steps. Step 1, choose your playground supervisor. This is the software called a hypervisor. For your personal computer, there are 3 fantastic and most importantly free options. The The first is VirtualBox. It's owned by Oracle, it's completely free and open source, and it runs on Windows, Mac, and Linux. It is the Swiss Army knife of virtualization. It's not always the prettiest, but it is incredibly capable and a perfect place for beginners to start. The second option is VMware Workstation Player. This is the free for personal use version of a very powerful corporate-grade product. It's known for being a little more polished and sometimes a bit faster than VirtualBox, especially with graphics. If you're on Windows or Linux, this is an absolutely stellar choice. The third option, if you're a Windows user, might already be on your computer. It's called Hyper-V. It's Microsoft's own built-in hypervisor. You just need to have a Pro, Enterprise, or Education version of Windows 10 or 11 to enable it. It's incredibly powerful and integrates perfectly with Windows, but it's a little less user-friendly for absolute beginners compared to the other two. My advice? Start with VirtualBox. Download it, install it. The process is as simple as any other application. Step 2. Get an operating system to install. Your virtual machine is an empty box. Needs a brain. This brain comes in the form of an ISO file, which is essentially a digital version of an installation CD or DVD. And you can get these legally and for free. The best place to start is with Linux. Go to the official website for Ubuntu, one of the most popular and user-friendly versions of Linux. You can download the latest ISO file directly from them, completely free of charge. It's a fantastic way to explore a whole new world without any cost. If you want to experiment with Windows, you can join the Windows Insider program. Microsoft provides free ISO files of their pre-release versions for people to test. It's a great way to legally get a Windows ISO for your educational sandbox. Step 3. Build your first virtual PC. This is the fun part. Open up VirtualBox or VMware, and you'll see a big button that says New or Create a new virtual machine. Clicking it starts a wizard that will walk you through the process. It's going to ask you a few questions that sound technical, but are actually very simple. It'll ask how much RAM you want to give it. Think of your computer's total RAM, say 16 gigabytes, as a full pizza. Your main computer needs a few slices to keep running, and you can give the remaining slices to your virtual machine. For a Linux VM, giving it 2 or 4 gigabytes is a great start. It'll ask how many CPU cores. Same idea. If your computer's processor has 8 cores, you can lend 2 of them to your VM. This ensures both your host machine and your virtual one run smoothly. And finally, it'll ask about the hard drive. It will create a single big file on your actual hard drive that acts as the virtual machine's own separate hard drive. You can decide how big you want this virtual drive to be. For a simple Linux install, 25 gigabytes is more than enough to get started. Once you've answered those questions, you'll tell it where to find that ISO file you downloaded, and you'll click Start. And right there, on your screen in a window just like any other application, you will see a computer booting up for the very first time. A computer that you built. A computer that exists only within your own machine. From there, you just follow the on-screen instructions to install the operating system, just as you would on a real physical machine. That first boot up is a moment of pure magic. It's the moment you realize the true, almost limitless potential of the machine sitting on your desk. You're not just running software anymore. You are creating entire systems. You are building worlds. So my challenge to you is this. Don't just let this be another interesting video you watched. Let this be the catalyst for you to take action. Tonight or this weekend, download VirtualBox. Grab an ISO for Ubuntu and create your first virtual machine. It doesn't have to be for a grand purpose. The purpose can simply be because I can. Follow your curiosity. See what happens when you delete a critical system file inside that safe virtual environment. Learn how to set up a simple web server. Try a different version of Linux like Mint or Fedora. Break things. Fix them. Learn. The digital world you create is yours to command, to shape, and to understand on a deeper level than ever before. The barrier to entry is gone. The cost of experimentation is zero. The only thing required is your desire to explore. We've come to see our computers as these sealed boxes. These mysterious appliances that we use but don't truly understand. A virtual machine gives you the key. It lets you pry open that box, look inside, and start building your own engines. So the question is no longer what can your computer do? The question is, what worlds will you build inside it?